Welcome to a class on regression analysis. Linear regression analysis is important for forecasting. So those that are taking economics, POM, as well as managerial economics must understand this aspect of forecasting. Linear regression equation has three main purposes. Number one, to predict a trend. Number two, to ascertain the direction of the two variables, whether they're positively or negatively related. Number three, to ascertain the strength of the relationship between the dependent and the independent variables. So you need to understand a few key terminologies. What is a dependent variable and what is an independent variable? What is a dependent variable and independent variable in regression analysis? And what is a regression formula? So when I'm discussing in regression analysis, a dependent variable, it is known as the outcome or response. This variable is the one we use to explain our focus of analysis. We also have an independent variable, which is called the predictor. It is simply an input. So if I'm going to define this in my econometrics way, I will define it a little bit complex as follows. So the relationship between two variables is examined by linear regression, where we have the dependent and the independent variable. The dependent variable is known as the response or outcome. That is denoted by the letter y. So y in the regression equation is our response. So y is equal to a plus bx. Then our independent variable is known as a predictor, which is x1 or x2 or x3. It is actually the input of our regression equation. So when we have a regression equation, we're basically trying to find what A and B are. Okay. So in this, so I haven't dropped this part of the board. In this question, we're going to learn how to input data. Not knowing what calculators you have, what calculators do we have on board?
I have daily Casio.
All right, so we're going to have daily and Casio are the same category. So we're going to have 1, 2, 3, 4, and 5 variables. 1, 1, 2, 2, and 4. So we're going to fill in this chart. So xy, x squared, and y squared. So when you multiply this, we have 1, 2, 6, 8, and 20. Here we have 1, 4, 9, 16, and 25. Here we have 1, 1, 4, 4, and 16. You're getting where the figures are coming from there, right? And then this is summation of x, summation of y, summation of xy, summation of x squared, and summation of y squared. When you total up here, you're going to get 15, 10, 37, 55, and 20. This is 26. So this regression, I said, has three key variable importances. Number one, to predict. It's called a prediction equation. No wonder the formula is given by the following prediction: y is equal to a plus bx. Where our b is given by n x squared n xy minus summation of x and summation of y over n summation of x to the power 2 minus summation of x to the power 2. So n is the number of parameters there that we have. We have the rows which we have as 5. So if you substitute the variables that we have there, xy is 37, x is 15, y is 10, and n is 5, and x squared is what? 55, and x to the power 2 we get is what is our x? It is 15 to the power 2. When you compute this, you're going to get your b as 0.7. So this is the part of 0.7 we're going to put here. Then our a is simply summation of x over n minus the same b we've calculated, summation of y over n. So in this context, we're going to have what? 15 over 5 minus 0.7. Then here we have what? Summation of y, which is 10 over 5. If we compute that, we're going to get negative 0.1. So y is equal to what? Negative 0.1 plus 0.7 x. Now this a is called the coefficient. B is called A is called the slope or the coefficient of x. Our b is coefficient of x. Then a is called the y-intercept or the intercept. So you can enter this data on a computer, on a software, and this data can come out in a format that looks like this. So you'll be asked to come up with a regression equation from this very format here. So what is our y-intercept? Negative 153.4. That is our variable or slope, 0.707 or 708. So what is the regression equation there? So what is our A in short? Our A is the y-intercept, and our B is the slope. So from here, we can simply say our A is what? Negative 153.4. Our A is negative 153.4. And what is our B? Our B in here will be 0.708. 0.708. So together, what is our regression equation? Who wants to try? What is our regression equation? Negative 153.4 plus 0.708x. That is how we write this regression equation. Are we together?
Yes.
So it is used to predict. It is used to predict Okay, so for this context, we'll ask you to predict what y is when x is 100. So just substitute 100 in there, then you expand it and solve it. That is how the prediction happens. So let's go back to our question here. When you are done with filling in this table, you can choose to use this formula or a shorter formula. The shorter formula which we have is calculating the sum of square xx, sum of square yy, sum of square xy. So here, the formula is summation of x squared minus summation of x to the power 2 over n. So in this case, we're going to have summation of x squared was 55, summation of x was 15, the power 2, our n was 5. So when you compute that, we get a 10. Here, summation of x, y squared minus y to the power 2 over n. So this is 26 minus what? 10 squared to the power 5. When you compute that, you get a 6. Then this formula is summation of xy minus summation of x, summation of y over n. So this is what? xy, what do we get? 37 minus x is 10 times 15 divided by what? 5. So this will give you a 7. Then find your slope. The formula is simply xy over xx. What is our xy? 7 over 10, which is 0.7. Our a, we calculated it the normal way. We found 0.1 negative. Our arrow is giving you direction, whether you have a negative or a positive relationship. And the formula is given by xy divided by xx times yy. And here, we're going to calculate our xy is 10, is 7, our xx is 10. So this will give you 0.9003. So here the direction is simply a positive direction. So r simply means x and y are positively related. Then r squared will give you the strength of the relationship, whether it's strong or weak. It's above 50%, it's strong. And you may explain it in terms of the percentage. So when you square that one to the power 2, what you're going to get is 0. What? 8, 6, 7. 0.8167. So it simply means that 81.67% of y is as a result of x. So 81.67% of y is due to x. So if you're using the table that I wanted you to know, this one here, you can interpret our r squared is 0.979. What does it mean? 97.9% of y is due to x. All right? And 7.79 is due to x. So now we can go to this question here. This solution, I use regression to help you understand. I use the software to just quickly do my part, but the question here was find the linear regression and suggest the weekly rate at which his sales are rising. So when you enter this, you're going to get the values of A and B. It's a regression. Then predict the consumption for temperature at 65 degrees. So where there's x equals 65, so we're going to get the prediction of negative 1.07. So it's used for prediction of power consumption. So this question here was looking at what? Okay, it was looking at something else, but if it was looking at the temperature, they're going to give you a figure to predict. Okay, are we following? Are we following?
Yes.
Yes.
Okay, let me now go to I have 9 minutes. I said up to 9:30. Let me go to the QM Bible. The questions came from the QM Bible. So I'll look at the question to do with the hours of study. The hours of study. And also I use take advantage to use hypothesis testing in this question, since I've taught you how to use hypothesis testing. All right. So we're given a following question. Calculate the coefficient of correlation and to test the significance of the regression line. So here you enter this data in the boxes as you do, X, Y. You understand what's happening there, right? So the lecture will be fair enough to even giving you the totals. So the totals will be given here, here, here. So to find R, you can use this long formula. This is SSXY, SSXX, and YY. It's the same thing here. So when you enter these, you will find your R, which is 0.82862. So this means that the positive relationship. You square it to tell you how much of X affects Y. Now, we need to test the regression line. So to test the significance at 5%, step 1, you can say R is equal to 0 or R is not equal to 0. When R is equal to 0, it means there's no relationship. When R is equal to 0, it's not equal to 0, it means there's a relationship. So you need to use a t-test because there are less than 30 samples. So the formula for us to find the t calculated is 1 minus R squared over n minus 2. So our R we found is 0.862 over 1 minus R squared over 6 minus 2. N minus 2 because we're dealing with the linear regression x and y. If they were x, y, z, it would be n minus 3. But here the 2 is coming from the fact that we're dealing with what? A linear regression. So just master this formula. When you compute this, we get 3.4. Now, how do we read the t-table? We have two steps in reading the t-table. Number one, find the level of significance, 5%. Number two, it's a two-thirds, so half it. So 2.5, half of 2.5, half of 5% is 2.5. Number three, use a degree of freedom. By degree of freedom, we're using n minus 2. So 6 minus 2 is what? 4. So let's read under 2%, 5%, and under 2. So you need to know where the t-table is. It comes right after what? The normal distribution table. So this is a t-table. So usually they'll give you this in decimal point, 0.025. So remember I said 5%, half of 5%, and n minus 2. That is 6 minus 2 is 4. So we go to 2.776. 2.776. So that is where 2.776 is coming from. So when we go into the table, 2.776. So we go back to our diagram here. Testing this at 2.776. So n minus 2 with degree of freedom. So we are going to compare 3.40 and the 2.776. This is coming from the table. So step one, like I said, it is state the hypothesis. Hypothesis is there's no relationship at all. You say R is equal to 0. R is not equal to 0. You can even use P. Step 2, the level of significance is 5%. Step 3, the decision rule. Okay, T calculated, alpha over 2, n minus 2. So reading under T, 0.025, comma 4. So we found 2.772. Okay. So here we're going to have this two-tailed test of a T. 2.772, 2.772. So we accept and reject here. If we reject, it's good in regression, meaning the test, there's a significance in the regression line. So step 4, calculate the T calculated, which is what? R over 1 minus R squared over n minus 2. So here, R was what? 0.862. Then here we have 1 minus 0.862 squared over 6 minus 4, which we found as 3.42. 3.42 is in the rejection region. So what is our conclusion? Conclusion is we reject what? HO. Are we together? Chiluba, are you there? Miriam, are you there?
Yes, I'm here.
Are you following Nosiku? Are you understanding?
Mr. Collins, I think you lost me when we came to reading the T-table. So I wanted to ask when you were done with the question.
Okay, the T-table is one thing I've never taught before. So it's the first time I can understand. Liner regression, when you're reading the T-table, for instance, I give you 5%, and you have 2 columns. Your n is 10. How do you read this? So you divide 5% divided by 2, it's 2.5. And n will subtract a 2, which is under 8. So you get 5% under 2.5, then you go to 8. The reading is what? 2.306. Suppose I give you 10% and your n is what? n is 8. So what do you do to this under regression? Divided by 2, which is 5%. And what do you do to the 8? Subtract minus 2, which is what? 6. So you go 10% under 5%, then you go to 6. 6 will be 1.943. This is when we are dealing with a linear regression. Are we together?
Yes, I understand now. Thank you.
So in the context of the question, which of course he may not bring it this way, but I'm just saying in the context of this question that Sabao brought, and he asked you to test. After finding your error, which one is our error? Our error is 0.989. So error over 1 minus error squared over n minus 2. You calculate if your t was maybe 5. But how do we read this in the t table? Our n is what? What is our n?
N is 6.
6, yes. So how do we read under 5%? So you divide 5% by what? By 2, which is 2.5. Then the degree of freedom is 6 minus 2, which is under what? Under 4. Is that clear?
Yes.
Yes.
All right. So we have concluded our class on regression, and you're ahead of the physical classes. Those of you are online. So we end here. I hope this serves you good.